Welcome. Today we'll explore Tembo's self-hosted solution, an all-in-one Postgres platform that lets you easily run the best of Postgres ecosystem within your own environment, without the complexity and hassle of setting it all by yourself. This powerful platform unlocks diverse use cases for you. By self-hosting Tembo, you gain complete control over your data, infrastructure, and security. Your data stays within your environment, enhancing performance and ensuring compliance with specific requirements. Moreover, Tembo's self hosted database can be a cost effective choice as it's optimizes CPU and memory usage, making it ideal for organizations with significant or complex data management needs. Let's see how you can deploy Tembo using Helm charts on your Kubernetes cluster. So I'm going to be following our documentation for installation. Uh, Before we get started, we have to make sure that we have all the prerequisites. So you can find the list in our documentation and mainly have a Kubernetes cluster. In this case, for the demo purposes, we'll use the EKS cluster, but we support all three major cloud providers and also any other Kubernetes cluster. So once that's done, you need to prepare for Tembo installation that has a bunch of steps that prepares the cluster for installation of the Helm chart. So I'm going to copy this command, go to my terminal, and run that command. And here's my Kubernetes cluster that is up and running that I'm going to be using to install Tembo on. So I ran that command. Now, if I go back, I'm going to add the Helm repo and update so it has the latest Helm chart. I'm going to copy this command here and go to my terminal, run it. Then as you can see, I already had it added, and now it ran and updated to latest Helm chart. After that's done, the next step is to do a Helm install. I'm going to go back to terminal and run the Helm install command here. And it takes about a minute for it to start provisioning various pods. So as you can see, it started provisioning various pods. And once the installation is fully done, all the pods should be in the running state. Next up, we're going to grab the external IP for one of the services called traffic. We grab that and we go to our Route 53 hosted zone here, and then update the A record to the correct load balancer. So I copied it and I'm updating it so it's using the latest load balancer. In your case, if that entry is not there, you will have to create a new A record and hook up the external IP. It takes some time to propagate, about a minute. Now that we have the Tembo self-hosted setup done, I'm going to go to app.demo.full-URL, go to that, and as you can see, I end up on the registration sign-in page for Tembo. And this is the instance that we just deployed. So I'm going to use this Google sign-in option here, pick and log in with my Google creds. Once I log in, you can see that I get an option to create an instance. When I click that, I'll get a list of pre-built stacks. Stacks are pre-built use case optimized Postgres deployments. And the Vector DB stack, which is what we are going to use today, simplifies working with embeddings in Postgres. And especially for self-hosted deployments, your sensitive data stays securely within your environment, helping you meet compliance requirements and adhere to internal security policies. So I'm going to go ahead, pick this Vector DB stack, deploy next, and then I'm going to name it Vector DB1. And then you can pick various options here. I'm going to pick memory optimized. You can also do storage auto scaling or HA. or increase the storage here as well. Uh, Now I'm going to click deploy now. And as you can see, it started provisioning the instance. And then if I go back to my terminal, um, you will see that there are pods coming up for the instance that we just provisioned. So now that the instance is fully provisioned, I'm going to go here, copy the connection string, and then go back to my terminal and paste the connection string here and log into the database. And if I do /dx, which will give me the list of extensions, you will see that there are extensions like vector, vectorize, and vector scale that are specific to the vector DB stack that are installed along with the instance. Tembo platform automatically also takes backups for your instances and provides an easy way to restore from backup if needed. Since the Tembo platform is built on Kubernetes, you gain all the advantages that Kubernetes offers. With the self-hosted option, you can also have the flexibility to configure the environment according to your specific needs, such as choosing which VMs to use, schedule Postgres pods on particular node using affinities, tolerations, and more. In summary, Tembo Self Hosted offers a powerful, scalable, and secure Postgres solution, perfect for managing a fleet of Postgres instances at 1/3 the cost, while providing a modern user experience. Whether you are building AI applications entirely within your own environment or simply seeking an easy to deploy, manage, and upgrade platform, Tembo Self Hosted is ideal for teams of any size. So, ready to take control of your data? Deploy Tembo Self Hosted today and unlock the full potential of Postgres on Kubernetes. Thank you for watching. For more resources to get started or to schedule a call, visit our website tembo.io.